Welcome, everybody. It's my pleasure to introduce Tainan Felipe. Tainan has been working on the BigBlueButton project for over 6 years. He is a member of the core team. And what he's going to show you today is actually one of the most probably influential or beneficial refactoring that is now going on in BigBlueButton. So I think you'll be pretty impressed with all the work that's being done that's going to hit both client and server and have an across-the-board improvement for their architecture and the product itself. Shannon, over to you.
Thank you for that. I will be talking about the GraphQL architecture and review and the migration strategy. At first, the reasons for be moving away from Meteor are primarily due to the limitation of running Node.js, which is single core architecture based, which makes scaling costly when dealing with the multiple instances to avoid an overload on BBB usage. Another factor is that Meteor's architecture requires to store the entire state of the meeting in the client side. All the messages should be loaded in the client side. All the users should be loaded in the client side, which leads to increased resource usage as the meeting progresses in both sides, in the client side and the backend. By migrating to GraphQL client, we will have great control over the loaded information on the client, allowing us for better resource management on the client side. We can address specific cases using GraphQL, such for example the chat and the user list, that are components that has a high data density and a lot of updates over the meeting. We can so loaded a small chunk of data for that cases and have a better control of the reactivity of the carries on the GraphQL part. And the tools also allow us to improve the performance in the case of where we could make pagination. And in the new architecture, we don't load more all the users. We just load the users that are shown in the user list, the messages that are shown in the chat list. I'll be talking now about how the architecture is designed in the current version of BBB, still using Meteor. It includes the 2.6, 2.7. In our current architecture, we have ACA managing the state of the meeting and sending message to Meteor through Redis. So Meteor register the messages in the MongoDB and replicate it for the client side. But it has some limitations. For example, the nodes bottleneck because it's a single thread. And when the server is overloaded, it takes increase the time in the load screen for the users that are joining a meeting that's running, and also makes the client unresponsive in the cases where it depends of the server response. For example, a presentation change or a message being sent in the chat. With the new architecture, the ACA will directly register the state of the meeting in the Postgres in a way that's accessible for the Azure and the BBB client to consume the information. And also we have implemented middleware The middleware in that case is just a tool we have made for control the connections between the client and the server. It's more for security reasons. In the example of if a user is banned, we don't want this user to connect to Hazora, so the middleware blocks it. And all the tools we choose to use, like Eka, Postgres, GraphQL, Hazora, the middleware that is writing Go, all the tools are scalable. And with the GraphQL protocol, we can limit the information sent and used by the client side. That's it about the new architecture. And following our migration strategy, we have a temporary architecture. We have created this temporary structure where the client consumes information from both Meteor and GraphQL. We have chosen to follow this approach to avoid interrupting the development timeline of the new features while gradually migrate one component at a time to the new stack. So also we have defined a roadmap. The roadmap we made focusing on removing the meter subscription that we have in the client side uh, to have the benefits of the new architecture of the GraphQL. So, for example, we have listed mapped all our subscription and it identified all the components within the client that rely on each subscription. That allow us to follow this roadmap, removing a specific subscription at a time. This approach allows us to have the benefit of have the performance and flexibility of the GraphQL at the same time that don't block the other users or the other developers to migrate to keep developing, fixing, and adding new features to BBBB. We are also place emphasis on isolate each component because in the old way architecture of the client side, not all the architecture, just the architecture of the client side, we initially thought it was a good idea to have shared services like the video service that is consumed by all the components and style component that's used by a few components. The main problem that when we are fixing a bug that involves this service, you could cause a side effect like changes the style of a button and it changes the styles of all of the buttons of the client. That's not good. So we are focusing on have isolated component that fetches all data it needs. It had some challenge because we don't want to have a small number of queries being sent to server by client. At the same time, we want to reduce the handlers of the components to improve the performance. We started isolating a few components, not a few isolated components that have all the styles they need, all the data they need, and also we defined a few common components, common carriers that are that are globally used by the clients, and they are also flexible to be styled for each component, not causing side effects in the other components. Now, in the current 2.8, we have three successful cases of migration. The first one that was our proof of concept is the participant list. We choose to migrate it first because it involved a highly resource intensive subscription, because that subscription is updated, contains all the users loaded in the client side, and also is updated in every user change. The user joined, the user talked, the user changed his status, updated this query, and send a lot of events for the client side. So it also could explore the usage of the GraphQL of the pagination. In the new participant list, we just load a subset of users, like the first 50 users. And while the user goes scrolling, we start to load more users. And also you could experiment the case of if the user list is not mounted, the server, the client's not consuming data from server, he stops the subscriptions and make the client lighter for server and for the client itself. The other case was the chat. That one, we explored the shared queries, because using Apollo and with GraphQL, we could every query that is equal have the same reference. When they send it, the Apollo sends it to server. He duplicates the queries and sends just one query to the server. That's improved performance because we could have multiple components consuming the query query, but for server is just one. In the chat, we focus on the pagination and shared queries, because if you have, for example, the components using the same query, for server it's one query. So we have also developed a custom hook for that cases, where that was very inspired by use selector Redux. And Redux has a hook that you can get a projection of the state of unfilled, and it will not render until it field changes. So we made the same for the queries on the BBB. So we have a hook that you can project a small set of the information of a subscription, and it makes the client perform better, because it only renders the component when this subset of fields changes, and the Apollo will make the dupe of this information for the server. And so we have the best performance of both sides. The idea also in this migration is make the client side the most efficient possible. So we are always worrying about the renders of the client. And also we made the pagination of the chat to make it more performant, just loading the last fifth message for the ones that following the tail, and load incrementally as the users scroll up. That we will not load anymore like in the 2.6 and 2.7 where we load all the messages on the client side. List more list, but certainly not lastly, but certainly not least, we migrate to the talking indicator component. This component relied on a subscription with a high volume of updates. By migrating it to a GraphQL, we are able to limit the access to a smaller subset of users, resulting in improved performance on the client side. This migration was crucial into making the client more efficient and responsive because the talking indicator is based on the voice users. Everyone that in the audio now on listen only or in talking mode is a user in the voice user, and it would be loaded in the client every time. Also, if it's not changed during the meeting. And for talking indicator, the only needed information is the last 8 users that talked. So using the GraphQL query, we could limit it and filter for the users that talked or spoke to show it correctly in the client side and reducing the data consumption. And that's it about my presentation about the client side. If anyone has a question, feel free to question me about the migration. That's it.
Really good, Tainan. There's, I'll ask a question while others feel free to type in the chat. Uh, there's a lot of optimization that's going to go on, and you talked like qualitatively on it. Do you have any quantitative, like when you refactor the user list? Do you have a sense of like what was the reduction in messages going back and forth or response time?
Yeah, yes. We don't have a full stress test yet. Thiago's working on it, but in certain users in the ACA, not loading clients on the meter because we think the a limitation is choose the meter number of connections. But we were able to join with 5,000 users. And if the user is not scrolling down, only the first 15 are updating, and the other users just exist there, and there's no problem there's no more hinder than that.
Okay, so I have to ask, please, nobody tweet that we now support 5,000 users. This is just a limit.
Yeah,
This is a
it's a
controlled.
control test. Yes, it's a control test.
But again, this doesn't. Uh, these guys have been working on it for a while. We started it at Berlin. There's just some really amazing work going on, and like, I think this might be one of those sessions where it's like, yeah, these guys talked about something called GraphQL, and then when it gets into the client, there's a lot of people working on this. When this gets into the core of the client, um, from what I've seen, the scalability increases, the CPU performance on the server, the CPU requirements on the server drops, the responsiveness of the client increases, and the complexity of the code reduces. Like if you ever look for a feature that just hits across all kind of components, um, the elegance of the interface, of the implementation, the responsiveness for the client, the user experience, the server requirements, like this is going to hit all of it. So, yeah, well, okay, but you can see we're getting there. We're, we make fun of the comment about like, 5,000 concurrent users, but what we really want is, what we'll do as we do in the past, the same thing with the video. Once we get the capabilities in, we'll stress test it and we'll publish graphs showing like before and after and try to come up with some real world scenarios. We have the ability in the project to create 1,000 users or 2,000 users or more. Um, we will be able to stress it. Actually, Chan and Miro pointed something in the chat. We recently hosted 700, observing that memory consumption consistently or constantly increased with constant number of participants. I suspect
Yes.
this will be helpful. This what you're doing will help
Yes,
out in this scenario.
you will be very helpful for that case because you not it's just loaded the need information. We are focused because in the current architecture, every data is loaded for the client side. The average 700 users loaded for the client side. In the new architecture, it will not be it will not happen. Uh, the idea you make the clients just load the information that's needed for that user, and also make, for example, if the user the admin server wants a server that has reduced features for a viewer, it will affect performance. For example, if the admin user disable chat in the meeting, no, for the viewers will not receive the message, and so will not be loading anymore. Currently, if you keep running a meeting with a chat independently, if the user is accessing it or not, the message are being loaded.
Right. So you can think about it in the early days when we built on top of Meteor, like this was all good. Meteor simplified a lot of things for us, and in
Yes,
classes which point,
Meteor make the BBB in HTML5 possible, uh, but for scalability, we are needing a new tool. That's it.
yeah. And what you referred to as Hasura was a middle layer that you guys were writing on top of the GraphQL engine for BigBlueButton. Is that correct?
Yes, the Azure it's a low code tool to make a GraphQL API. Having the database, you have a way to create permissions and structures for GraphQL in Azure. So that's the tool that is speeding up our development in the GraphQL part because we have all the data in Akka, so we just need put it in the Postgres, and Hasura makes API for it. But I will not talk much about Hasura because I will be spoiling about the Gustavo's presentation.
All right. Tianan, thank you. Thank you very much for sharing this. I think people can start to get a sense of what the impact will be on the project for scalability, responsiveness, maintenance of code, efficiency, reduced bandwidth, reduced CPU. It's really quite amazing. All right, I'll stop the
Yes.
recording. Thank you, Tiana, for the presentation.
Thank you for the invite.